Hi Beamer, so today we're going to be looking at the science behind floating objects, and we'll be looking at that through the concept of density. So looking at some real world examples, density is used to solve a lot of different problems in our world. Looking at oil spills and how oil stays afloat in water, looking at ships and how they can stay afloat in water, looking at different pilots and how they use density to figure out the optimal altitude for them to fly. Density is used to help solve real world problems and challenges. So in this module, we'll be looking at density and its properties and its relationship with buoyancy. Next, we'll be looking at the interactions between water and oil and its density and polarity. And finally, we'll be looking at the Archimedes principle and how engineers use that to help create ships that stay afloat in water. Some questions you guys can think about is, why do helium balloons stay afloat, but normal balloons don't? Why do hot air balloons float in the air? And finally, why do ships stay afloat in the water, but submarines sink in the water?
Hey guys, today we're going to learn about density. Density is the physical property of matter that defines how compact an object is. In other words, density is the amount of matter in a given amount of space. So for example, if you add a ceramic cup and a styrofoam cup, can you guess which one is more dense? The ceramic cup. It has more material making it up. Density can also be defined in the formula of mass over volume. Mass is the amount of matter in an object, and volume is the amount of space that it takes up. Remember that mass is not the same thing as weight. Weight is the measure of gravitational force on an object. In chemistry, the density of an object is often compared to the density of water to determine if the object will float in water. Buoyancy is the ability of an object to float in fluids like water. The density of water is 1 gram per cubic centimeter. If an object has a density smaller than 1, then it'll float in water. And if it has a density higher than 1, then it'll sink. Let's see what this relationship looks like in a demo. The materials you will need are water, a tub or 2 cups, 1 orange, a can of regular Coke, a can of Diet Coke, 2 eggs, 6 tablespoons of salt, and 1 spoon. It's okay if you don't have all these materials. We're going to show what these demos look like in this video. First, let's set up our tubs by filling the 2 cups with water or 1 bigger tub with water. Then grab your orange. Do you think an orange with a peel will float? Or do you think an orange without the peel will float in water? Take a second to make your guess. Go ahead and place the orange with the peel in the water tank. Take notes on what you see, and then take out your orange, unpeel it, and place it back in the water. We're going to show both of these in this demo video. The orange with the peel floats. That's because the orange peel has pores filled with air, and air is less dense than water. So even though the orange has a bigger volume than an unpeeled orange, it has a smaller mass, and therefore a smaller density. Now let's try with a can of regular Coke versus a can of Diet Coke. Let's predict which one we think will float. Remember, objects that float in water are less dense than water, and density is defined as mass over volume. Alright, let's test our hypotheses. The regular soda sinks. That's because it has a greater density than diet soda. Diet soda has no sugar in it, giving it a smaller mass over the same amount of volume as a regular soda. Cool, right? Alright, here's our last demo. We're going to compare an egg in water and an egg in salt water. Which one do you think will sink or float? Pause here to discuss. Let's see the results. The egg in tap water sinks while the egg in salt water floats. The egg in tap water will sink due to being denser than water. When we add salt to the water, the egg will float because salt adds mass to the water, thus increasing the density of the fluid. Since the egg is less dense than the salt water, it'll float. Feel free to try this with other objects in home that are waterproof. Hopefully you get a better sense of density and buoyancy. Let's move on to Module 2.